Welcome to qnawire.
In this problem we have two spheres with an initial velocity colliding off each other in all three physical dimensions. We've been test defining the final velocity of one of the spheres after the collision. So let's start with what we know. We know the masses are going to be constant, m1 and m2. M1 is 0.5 kilograms and M2 is 1.5 kilograms. Now we don't know what type of collision this is, so we're going to just use the standard conservation of linear momentum equation. To do that, it would just be M1 V1 initial plus M2 V2 initial equals to M1 V1 final plus M2 V2 final. So, for part A we're going to find the velocity if we know the final speed of one of the balls. Let's put everything we know into this equation. So, mass of 1 is 0.5. The initial velocity of 1 is 2I minus 3J plus 1k. The mass ball 2 is 1.5, and the initial momentum or initial speed of that is negative 1I plus 2j minus 3k. So that's our initial momenta of each ball, and this is going to equal to the final momenta of each ball. Now we only know the velocity of one of these. So let's figure out what it is going to be. We only know the velocity of the mass 1 ball. So 0.5 multiplied by Vf, which is negative 1I plus 3J minus 8K, and that's plus 1.5 V2F. So from here what we can do is expand out all of our parentheses and figure out how many i's, j's, and k's we have on both sides. So let's do that now. From the first one we have 1i minus 1.5j plus 0.5k minus 1.5i because of that negative 1 plus 3j minus 4.5k, which is equal to negative 0.5i plus 1.5j minus 4k plus the 1.5 V2F. Then by combining like terms and rearranging, we end up with, well, we'll combine like terms first, negative 0.5i plus 1.5j minus 4k is equal to 1.5 V2F, and then the same thing, so minus 0.5i plus 1.5j minus 4k. So we'll bring these three onto the other side of our equal sign, and actually what you should see is that they are both the same. So V2F is actually equal to 0 meters per second. And for it to be 0 meters per second, it has to be inelastic, because they're both moving at the same initial or same final speed, Vf. Okay, part B. We have a similar situation now, but we have a different final speed. So I'm going to use what we ended up with in the first part of the equation, in part A, and have negative 0.5i, because our initial speeds are the same, plus 1.5j minus 4k is equal to 0.5 multiplied by its new final speed, which is now assumed to be different, that is negative 0.25i plus 0.75j minus 2k plus 1.5 V2F. So in a very similar situation to what we were in just a moment ago. Again, I'm going to expand these parentheses on the right hand side, and then we'll rearrange. So, expanding that out gives us negative 0.125 I plus 0.375 J minus 1 K plus 1.5 V2F. And now we'll rearrange. We'll bring everything on this side, apart from the V2F, over by adding or subtracting. So what we should have is negative 0.375I plus 1.125J minus 3K is equal to the 1.5 V2F. Then if we divide both sides by 1.5, what we should get for V2F hopefully is negative 0.25I plus 0.75J minus 2k meters per second. So that's the final speed of ball 2 with a different set of final speeds for ball 1. Okay, now part C, again very similar, except now we have an unknown variable in the k direction as well as an unknown final velocity for the second ball with the mass of 1.5. I'm going to start off again with the similar equations we had in the last question. Negative 0.5i plus 1.5j minus 4k. That's our initial total momentum. Again, the same thing. And that's equal to 0.5 multiplied by negative 1i plus 3j plus ak plus our, again, unknown 1.5 V2F. So I'll expand the parentheses here. We end up with negative 0.5 I hat and positive 1.5 J hat and 0.5 A K hat plus 1.5 VF. Now what we should see here is that 0.5I is negative on both sides and positive 1.5J is there on both sides as well. So what they do is go away and we end up with negative 4K hat is equal to 0.5 A K hat plus 1.5 VF. So I want to find out what A is equal to here, so I can just rearrange that real quick, and knowing that the final velocity has to be going in the K direction, that's going to help me. So I'm going to rearrange this in terms of A, so 0.5A is equal to 1.5 VF minus 4. Now I'll divide everything by 0.5. And what I'll end up with is A is equal to 3 VF minus 8. Now this is going to come in handy in a moment. Now we've been told that we have an elastic collision. So what that means is kinetic energy is conserved. So we're going to have to use that to help us find out what VF is going to be. So the equation for the conservation of kinetic energy here is going to be so add up all of the kinetic energies here, and that's equal to the final kinetic energies too. Make this quick. So we can substitute in everything we know for all of this. So let me do that for you right now. So that gives us this set of equations where we have 1/2 times the mass times the velocity squared. Now squaring the i's, j's and k's is actually easier than it looks. We don't have to do this as a double set of parentheses because the i's only interact with the i's because everything here is perpendicular. So we end up with something that looks actually not too bad. 1/2 of 0.5 times 4i plus 9j plus 1k plus 1/2 times 1.5 1i plus 4j plus 9k, which is equal to 1/2 times 0.5 multiplied by 1i plus 9j plus a squared k plus, of course, 1/2 times the 1.5 times v2f squared. Now, because this is kinetic energy, direction actually doesn't matter. So what we need to do is take everything in our parentheses and add it all together. So we end up with 1/2 times 0.5 multiplied by 4 plus 9 plus 1. So 1/2 times 0.5 multiplied by 4 plus 9 plus 1, which is 14, plus 1/2 times 1.5, and the same thing again, 1 plus 4 plus 9, which is 14 here, and then that's equal to 1/2 times 0.5. Here I have 10 plus a squared, and then of course plus 1/2 1.5 VF. Now I already know what A is because I calculated that right here, 3VF minus 8. So what I'm going to do is I'm going to substitute that in right here, and I get 3.5 plus 11.5 is equal to 1/4 multiplied by 10 plus 3VF minus 8 squared, and then plus 3/4 VF squared. That's V2F as well. I didn't write that in. So from here now I can expand the parentheses right here and come up with the solution. So I had 3.5 plus 11.5 is equal to 1/4 10 plus, and expanding those parentheses will give me 9 VF squared plus 28 VF plus 64 plus 3 over 4 VF squared. So 14 is equal to 2.5 plus 16 plus 9 over 4 VF squared. Sorry, this is 48. Plus 12 VF plus 3 over 4 VF squared. What you'll notice is that the VF squareds are now both in terms of fourths. 9 plus 3 is 12 fourths. And of course 12 fourths is 3. So 14, if we combine all of these things, 3 VF squared plus 12 VF plus 4.5. Here we have a quadratic equation that we need to solve using the quadratic formula in order to find out what the final velocity of the second ball could possibly be. This means we're going to end up with two solutions, positive and negative, based on the quadratic equation that comes out, or not quadratic equation, but the square root equation in the formula. So let me write that out for you as well. So we have to make sure that this is equal to 0 before we can do that. 3VF squared plus 12VF, and then you do 4.5, sorry, it's 18.5. 18.5 minus the 14 is 4.5. Jumped ahead of myself a little bit there. Okay. So then we can do the quadratic formula. I'll do that on the next slide. So remember, the quadratic formula is V is equal to negative B plus or minus square root of B squared minus 4AC all over 2A. Remember from our previous slide, A, B, and C is equal to 3, 12, and 4.5. So we just need to put those into this equation, and what you should get is negative 12 plus or minus the square root of 12 squared minus 4 times 3 times 4.5, all divided by 2 times 3. Now this gives us two possible values for V. We'll end up with negative 12 plus the square root of 144 minus 54, or negative that, and that's over 6, because 2 times 3 is 6. So by putting both of these into the calculator, you'll either get V as negative 3.58 meters per second, or it will be 0.419, also negative, meters per second. So those are your two possible values for V. But that's not all we have to find. We also have to find A. And A, if you remember, was equal to negative 8 minus 3V. And that's V2F too. I'm going to make sure I put that in there, V2F. So because we know what the V2Fs are going to be, A is either going to be equal to negative 8 minus 3 times negative 3.58, which comes out to be 2.74 meters per second, or A is going to be equal to negative 6.74. And remember, A was that variable inside in the k direction for the sphere. So there's your two values of v and the corresponding values of A for those final velocities.